Alright, so welcome to our today's lesson where we'll be solving a question which is under CVS or cardiovascular system. So the question is saying that a 40-year-old woman has an ejection fraction of 0.25 and the end systolic volume of 150 mils. The actual question now, what is the end diastolic volume of this woman? Okay, so let us first try to understand the question. In the question they have given us to say, this woman who is a 40-year-old has an ejection fraction of 0.25. So let us first try to collect the data here. So the data that we have is ejection fraction is given in the question to be 0.25 and the end systolic volume of 150. So the end systolic volume is equal to 150. Okay, and they are saying that what is the end diastolic volume of this woman? So we have to solve for end diastolic volume. So this we don't have. So now looking at these figures that have been given here, we first have to look for the formula that relates these three parameters that we have here. And the only formula that relates these three parameters, it is the formula for what? Ejection fraction. And it will be very easy for us to solve because we do have the ejection fraction, it is there in the question. So we're going to use the same formula for ejection fraction, which is ejection fraction is equal to the stroke volume divided by the end diastolic volume. Okay, so this is the formula now that we use to solve for what? For ejection fraction. So we do have the end diastolic volume. No, we don't have. Do we have the stroke volume? No, we don't have. So what do we do? So here, what we do here, let us first try to solve for systolic volume. Okay, that is now what we are going to solve for. So systolic volume here is given by end diastolic volume minus the end systolic volume. Now the bad part is we don't have the end diastolic volume. So what are we going to do? What we're going to do here is we're going to use this same formula, okay, this part which is of course equating to stroke volume. We put it there and we try to simplify the formula, the whole formula now for ejection fraction. Then we can solve because we've been given the other figures for ejection fraction and for end systolic volume, okay? So what I mean here is this. We are going to say the ejection fraction will now be equal to, instead of us putting the stroke volume here, we're just going to put the formula for stroke volume, which is end diastolic volume minus the end systolic volume, okay, over the end diastolic volume. We haven't altered the formula. Yeah. So now, what we're just remaining for here, it is to do what? To simplify this equation. Then the rest is history because we're going to now compute these figures. We're going to put them where they are going to be. Yeah. So we're going to say ejection fraction multiplied by this. What are we having? So we're having ejection fraction being multiplied by the end diastolic volume being equal to, if we again multiply this side, we're going to have end diastolic volume minus the end systolic volume. Okay, so this is now what we have here. So from here, what are we going to do? We want to make the end diastolic volume the subject of the formula. Okay, so here what we're going to do is, so this is now math. Okay, so this is not physiology. Yeah. So here what we're going to do here is just to simplify now this, okay, this expression that we have here by doing what? By taking this guy, which is the end diastolic volume, to this side. Okay, so what we are having here is we're going to say or we're going just maybe to take this guy this side, then we take everything here this side. Okay, it's one and the same. Or what we want is the end diastolic volume to be the subject of the formula. Okay, so what I mean here is this. We're going to say end systolic volume. So meaning we have taken this guy, this side it is negative, this side is going to be what? Positive. Okay, so end systolic volume will now be equal to what? The end diastolic volume minus, since we are having these, they are positive, taking them this side, they'll become what? Negative. So minus ejection fraction now being multiplied by what? End diastolic volume. Okay, so this is now the expression that we are having here. So from here, what we can do here is to multiply, since we have the end diastolic volume and the end diastolic volume again. So these two guys, they are doing what? They are repeating themselves. So what we're going to do here is do what? Okay, so the simplest way of solving this is to factor out the end diastolic volume, which is common. So what we are going to say is the end systolic volume, this side, being equal to, if we factor out the end diastolic volume, since it is common, we're going to have the end diastolic volume, since we have factored it out, open bracket, 1 minus the end, 1 minus the ejection fraction. Okay, so this is now what we're having here. If again we try to multiply this end diastolic volume times 1, again we are getting what? We are getting another one. Okay, we're getting another end diastolic volume. So meaning this is just correct. Okay, so from here, what are we having? What we are having is end systolic volume, this side being the subject. But what we want is end diastolic volume to be the subject of the formula. So what do? We just divide by 1 minus ejection fraction. Even this side, 1 minus the ejection fraction. Okay, so this side will divide, this side will divide. Okay, so what we are going now to remain with here, what we are now going to remain here with is this. So we're going to say end systolic volume over 1 minus ejection fraction will now be equal to the end diastolic volume, because these two, they did what? They divided. Okay, yeah. So this is now what we are having here. Do we have the end systolic volume? Yes, we do have. It's here. Do we have the ejection fraction? Yes, we do have. It's what? It's here. It's 0.25. So now, what do we do from here? So it's very simple. Very simple and very easy. So what we're going to do here is just to put them now. Put the values there and solve. Okay? The answer that we're going to find, it is now our final answer. So what we're going to do here is we now, okay, put the values there. End systolic volume is what? 150. So we're going to say 150. Just clear up this space. Okay, we're going to say 150 here, which is of course the end systolic volume, and the ejection fraction now. Okay, we put it where? There. So divided by 1 minus the ejection fraction, which is 0.25. 0.25. Okay, being equivalent to the end diastolic volume. So this will now be our answer after computing this. So we're going to divide now. We're going to say 150 divided by 1 minus 0.25. Okay, so the answer that I'm getting here is 149.7. Okay, so here what I'm getting is 149.7. So meaning, if we say 1 minus 0, okay, so we're going to do 1 minus 0.5 first. 1 minus 0.25, we're getting 0.75. Now, if we divide 150 divided by 0.75 is 200. So here the answer that I'm getting is 200. So 200 will now be equal to the what? To the end diastolic volume. So this is our answer. And of course in mils. Okay, so this is how you get to solve this kind of question. Okay.